In this video, I want to say a little bit more about trig functions. I'll remind you of the basic definition and shapes, and then I'll work through two examples that should be helpful for the homework, and we'll also set you up to do some more interesting exercises at the beginning of class on Thursday. So the basic trig function, start with sine. Trig functions are these wiggly things. Up and down and up and on they go. And the basic period of this is 2 pi radians. So it takes 2 pi sine t, and there's t. So it takes 2 pi radians for one complete wiggle to occur. And a wiggle is an up and a down. Then it would go up and down again. So of course not everything in life has a period of 2 pi. And I should draw, just for completeness' sake, that the top is 1 and the bottom is -1. So let's say the amplitude is 1. That's the distance from the middle to the top. The entire wave would be 2. So amplitude of 1, period of 2 pi. But more generally, we could have a function f of t could be a sine bt plus c plus d. So this green function here takes this blue function and changes it in ways that we talked about in class. So a, that changes the amplitude. That would stretch this entire function up, or compress it in if a was less than 1. This c would shift the function left or right. D would shift the entire function up or down, and B has the effect of compressing the function or stretching it out. So we know that the regular sine with no B, B of 1, has a period of 2 pi, and we know that when I take t and I multiply it by b, that makes everything go b times as fast. That would make the curve squashed in. It would go up and down much more quickly. So that tells me that the general period for this, the period, is 2 pi over b. So if you're handed a trig function that's not exactly t and you want to know what the period is, you use this formula. If you have a particular period in mind and you want to build a trig function that has that period in it, then you use this formula and you solve for b and put it in there. So before I do an example, I should also sketch cosine, some axes. Cosine starts at 1. Goes down to -1, and then comes up to 1. And so that would be 2 pi. So it has the same period. They both do their thing in 2 pi. And really they're the same function, it's just one happens to be shifted by the other. If I took this and moved it to the left, I'd have cosine. So this is cosine. There's cosine t. And this is sine t, and this is the basic formula for them. So let's do 2 quick examples to practice this. So here's our first example. Suppose we need to sketch the function f of t is cosine pi over 5t plus 3. So this will be a cosine function, so it starts at 1 and then it wiggles. Let's first think about what the period is. So we know that the period is 2 pi over b. And b is the thing that's in front of t. So b, this is b, pi over 5. So the period is 2 pi over 5. So the pi's cancel. I could multiply top and bottom by 5. The 5's cancel. And this would be 10. So the period is 10. So let's see. Let me draw some axes. There's t. There's f of t. So the amplitude of this function is 1. There's not any number in front of here, it's just 1. So this is a regular cosine function. It goes up 1 and down 1, up 1 and down 1. But the entire thing is shifted up 3. So here's the basic cosine function. It goes from 1 to minus 1. If I add 3 to it, it'll go from 4 to 2. So let me attempt to draw that. It's going to go start at 4. It's going to go down to 2, back up to 4, down to 2, and so on. So this is 4. That's 2. This is the amount of time it takes to do one complete cycle. From here to here, it does one complete cycle, and we decided that that was 10. So that's a rough sketch of this function. It's a cosine wave. It's shifted up by 3. So instead of being down here, it moves up there. And the period is 10 instead of the sort of default period of 2 pi. Here's one more example. Suppose we're given a graph of a function, f of t, and our task is to find a formula for that. What might a formula be for a function that wiggles like this? So let's see. Again, this looks to me like it's a cosine because it starts high and then goes down. The amplitude is going to be chu. The amplitude is how far it is from the midpoint up to the top or from the bottom to the midpoint. So the amplitude is 2. I should write that down. And the other thing we need to figure out is the period. So the period for this is 14. Why? Because it takes 14 time units for it to do one complete cycle. It starts here, it goes down, and then it comes back where it started from. So that's one full cycle. And remember that for a trig function, the period is 2 pi over b. Now in this case, we know the period and would like to find b. So let's see, the period, I guess I'll write the period is 14. 14 equals 2 pi over b. And I'll move the b over here and divide through by 14. So I'm going to get b is 2 pi over 14, which is pi over 7. And that's it. Now I have my a, I have my b. And oh, what else do I need? Let's see. I need to add 2 because this is shifted up by 2. So d equals 2. And now I can put it all together, and I'll get this. 2 times cosine pi over 7t plus 2. So this 2 takes a regular cosine and stretches it, so it's now twice as tall. The hills are twice as tall, the valleys are twice as deep. Adding 2 moves the thing up the graph, and then pi over 7, that stretches things out just enough so that the period is now 14. The default period is 2 pi, but if we put this b there, which we found to be this, the period ends up being 14. Lastly, it's worth noting there are a bunch of problems like this where you're shown a graph and you're asked to find a formula for f of t. There are actually many possible formulas that you could come up with. You could, in this case, it's pretty clear, this is sort of the natural choice, but there are times when you can get, it's equally natural to get different answers. So you could view this as a sine wave that's shifted to the left or something. So there's not a unique answer, which means if you have an answer and you look in the back of the book and it doesn't agree with the answer you had, it's not a guarantee that you're wrong. It might be that you had an alternative correct answer.